everybody, in this video we're going to learn how to calculate probability with the different counting methods we've learned so far. So take 3 deep breaths and let's make this math easy. Okay, so at the beginning of this unit, we talked about how the basic idea of probability is that the probability of any desired outcome equals the number of desired outcomes divided by the number of possible outcomes. And we did this with really simple examples like rolling a dice or flipping a coin or things like that. And what we're going to do in this lesson is we're going to use all of the counting methods that we have learned so far, like permutations and combinations, multiple combinations, and the different methods we talked about in the last video to be able to figure out the number of desired outcomes and possible outcomes for more complicated situations. So let's say, for example, you were trying to randomly guess a 3-digit PIN, and we want to find the probability that you'll guess it correctly. Well, basically what we need to figure out is we need to figure out the number of possible 3-digit pins, and then we need to figure out the number of correct 3-digit pins. So let's start off by figuring out the number of possible 3-digit pins. So remember, with a pin number, it's okay if the number starts with 0 because pin numbers can start with 0. So the number of options that I would have for my first digit is 10 because it can be any of the numbers 1 through 9 or 0. And then they didn't say anything about repeated digits not being allowed. So the number of options I have for my second digit would also be 10. And then for my third digit, I would also have 10. So the number of possible 3-digit pins is 1,000 because 10 times 10 times 10 is 1,000. Then I would want to figure out the number of correct 3-digit pins. Well, the 3-digit pin, whatever it is, the first digit has to be whatever the first digit is in the pin. So there's only one option for what the correct first digit is. Then there's only one option for what the correct second digit is, as well as the third digit. And so basically there's only one correct pin, which is kind of like self-explanatory. And when you divide those two numbers together, you'll find the probability of guessing the pin correctly if you just randomly guess. So 1 out of 1,000, if you divide that, you get the decimal 0.001. If you change that into a percent by moving the decimal over twice, you get 0.1%. So essentially, you have about a 1/10% chance of guessing the pin number correctly. So not very likely. Another example of this would be if you randomly chose a 7-digit number and you wanted to find the probability that your number starts with 28. Well, you'd start off by figuring out the number of possible 7-digit numbers. So remember, a 7-digit number cannot start with 0 because if it starts with 0, then it would be like a 6-digit number. And so you'd say, okay, well, I have 9 options for my first digit. But you can have a 0 after the first digit, so we'll have 10 options for my second digit, 10 for my third, fourth, fifth, sixth, and seventh. So the total number of possible 7-digit numbers would be 9 million. So I have 9 million different 7-digit numbers, and now I need to figure out the number of numbers that start with 28. So if I want my number to start with 28, that means my first digit has to be a 2. So I only have one option for what my first digit can be. If I want it to start with 28, my second digit has to be an 8. So I only have one option for that. But then after that, it doesn't matter what the rest of the digits are. So I'll have 10 options for my third digit, 10 for my fourth, my fifth, my sixth, and my seventh. So the number of possible outcomes is going to be a 1 followed with 5 zeros. So I think that's 100,000. And if you divide 100,000 by 9 million, you end up with the decimal 0.0111111. So it's about a 1% chance that you would randomly choose a 7-digit number that starts with 28. So the basic idea here is that you want to figure out the number of possible outcomes and then the number of favorable outcomes, and then you divide those two. So why don't you try this one on your own? Pause the video and then restart it to see how I would solve this one. Okay, so on this one, we're randomly choosing a 5-person committee from 23 males and 26 females, and we want to find the probability that the committee has exactly 2 males. So the first thing I'm going to do is I'm going to figure out the number of possible committees. So I say, okay, the number of possible committees total is going to be the total number of people that I have. So if I have 23 males and 26 females, the total is 49 people. So the first person on my committee, I could choose from 49 people. Then the second person, I'll have 48 options because it can't be the first person that I chose. Then I'll have 47 for the third person and 46 options for the fourth and 45 for the fifth person on my committee. Now on a committee, it doesn't matter who gets chosen first, second, third, etc. So I also need to divide by the number of duplicates. And the number of duplicates will be 5 times 4 times 3 times 2 times 1. And when I calculate that out, I get 1,906,884 possible committees. Now to find the probability, I need to figure out how many committees have exactly 2 males. So to find the number of ways that I could have a committee with exactly 2 males, I would start off by choosing 2 males. So I'd say, okay, well I have 23 options for my first male, then I have 22 options for my second one, and it doesn't matter which order I choose them in, so I'll divide by the number of duplicates in that choice tree. And then I need to say, okay, well that's the number of ways that I can choose 2 males, but if I want to have exactly 2 males, I also have to have 3 females to make up my 5-person committee. So I'm going to multiply the number of ways I can choose 2 males by the number of ways that I can choose 3 females. So I say, well, I have 26 options for my first female, 25 options for my second, and 24 options for my third female. And again, the order doesn't matter, so I'm going to divide by the number of duplicates, which would be 3 times 2 times 1. And when I figure out the fraction for the number of males, it looks like there's 253 ways to choose 2 males. And when I figure out how many ways there are to choose 3 females, it looks like there's 2,600 ways to choose those. So when I multiply both of those numbers together, 253 times 2,600, I get 657,800. And when I divide that by the total number of committees, which is 1,906,844, I get the decimal 0.34, and then it keeps on going. But basically, it's about 34% likely that if you randomly choose a 5-person committee, that committee will have exactly 2 males. And so that's how you would calculate that probability. So on your assignments, basically what you want to do is you want to use the different counting methods we've learned to find the number of possible outcomes and find the number of favorable outcomes for what your question is asking, and then divide those to find the probability of getting that outcome. So if you have any questions, let me know, and I hope you guys have a great day.